Hello, everyone. Thank you for joining us for our hands-on workshop, where we will see how we can make sense of the unseen world using AI, sensors, and IoT. I am Shruti Karolkar. I am Quality Engineering Manager at Mathworks, and today I look forward to talking about Internet of Things. Over to you, Sarah.
Hello, everyone. My name is Sarah Mohammed, and I'm a software engineer at Mathworks. And today I'll be talking to you all about artificial intelligence.
Hi, my name is Lauren Shore, and I'm a consulting application engineer at Mathworks. And I'll be talking to you today about using MATLAB Online and MATLAB Mobile, and talking about some of the ethics of AI as well. On to you, Lou.
Thank you, Lauren. Hello, my name is Walker-Hannon. Please feel free to call me Lou. I am an application engineering senior team lead. I'm another application engineer, just like Lauren. And for today, I'll cover some topics related to location data and how it has an impact related to a lot of the other work that my colleagues will highlight during the workshop. And thank you for joining us. So this workshop will provide us with the opportunity to explore how to obtain sensor data and use this data to explore the data science workflow. In terms of the tasks that we're going to implement during this workshop, they're connected to a number of real-world applications that entail exploring a scene. Often with archaeological, construction, and other similar sites, content is present, but is not visible to the human eye. Therefore, the use of sensors can help us determine what may be in the site and also assist with learning more about the scene, how the data was collected, and more. Next, my colleagues Lauren and Sarah will walk us through the logistics for this workshop. Let's get started.
Okay, thanks. I'm going to help provide a brief overview of the logistics for the workshop. We'll be using the following items during the workshop: a laptop and a mobile device. We recommend that you use the laptop to set up your Mathworks account if you haven't already, and that will be where you get access to MATLAB Online, plus files from MATLAB Drive. There is pre-work provided in the chat if you haven't set things up already. And if there's any questions during the workshop, please put them in the chat and we will have people monitoring it so that we can answer that. Next, my colleague Sarah will tell you more about MATLAB Online and the files for MATLAB Drive.
Thank you, Lauren. So this setup has three main parts. The first is going to be setting up your Mathworks account, then activating the workshop license to access MATLAB Online, and then finally getting access to the files for the course. So we recommend that you do all of these setup steps from your laptop, and please use the Google Chrome browser. Later on, you'll actually run the exercises from your mobile device in the MATLAB Mobile app, but for now you can do the setup from your computer. So step one is to create a Mathworks account in the Google Chrome browser. And please use an email address that you'll have access to throughout this workshop so that you get the verification email. Step two afterwards is to activate the workshop license using this URL that's on the screen and which we'll show you in the chat as well. When you open that link, you'll see the page on the right. And if you're not still logged into your Mathworks account, you'll be asked to log in first. Once you're logged in, though, you should see that button to access MATLAB Online, and this will activate the workshop license. So next, step three is to get access to the files. So from your browser, go to this URL, which will open up MATLAB Drive. MATLAB Drive stores the files for this workshop in the cloud under your Mathworks account, so you can run them in MATLAB Mobile. So on this page, click the Add to My Files button, and choose to copy folder to your MATLAB Drive. So please take a few moments to get set up, and we'll share a link to a pre-work document in the chat that has detailed instructions for all three of the steps we just described. And all of these previously mentioned links and other resource documents that are pertinent to the workshop can also be found in the GitHub repository on this screen. And we'll share a link to this with you during and after the workshop as well. So next, my colleague Lauren is going to provide us with an overview of the topics that we'll cover.
Thanks, Sarah. You probably came to this session today to learn about sensors AI, and IoT. We'll use the idea of exploring a scene to help tie these concepts together into a single application and help you better understand what all the different pieces mean. If you look at the image on this slide, you may notice certain items are visible to the human eye. Looks like a nice place to visit. However, have you ever wondered what might be underneath the surface? For example, there could be metal from various items within the body of water, but we may not be able to see that. We can use measurements of magnetic field strength to help determine the presence of the metal, however. We can also determine what an individual was doing when they collected the data based on their movements. We can use sensors from our phones to help collect these sorts of data. We can use AI to help classify our movement, and the data can be shared and aggregated using IoT, the Internet of Things. Overall, this data that we are collecting can assist us with making sense of what may be present, what the data collector may have been doing, and to analyze the connected data. We will implement steps that are part of the data science workflow on a mobile device. The steps that we will implement as part of this workshop are data collection, data visualization, and data analysis. So let's start with the sensors. Sensors are absolutely everywhere, even when you're not really aware of them sometimes. A sensor is a device which detects some physical property like temperature, humidity, and then responds to it. Here are some examples. You can see fitness devices, virtual reality devices, and wearable tech, such as this Owlet baby sock shown in this picture. This sock uses sensors to monitor your baby's heart rate and oxygen levels and track their sleeping patterns and send the results to your mobile phone. So what's in common across these examples? They all leverage a sensor called an accelerometer. We will be using this as one of the sensors in our workshop. Next, Lou will highlight some additional sensors.
Magnetic field strength is around us on planet Earth, whether it is from the Earth itself or from other objects. Magnetic field strength can be measured by a variety of devices. In fact, there's some apps that can help measure magnetic field strength. And one of the devices is the magnetometer. So most modern cell phones have a magnetometer, and we will use the sensor to measure the presence of metal in our local regions. Our local region in this particular case is a scene. This information can be important regarding a number of applications. One category of applications where there is some sort of study or survey related to a section of land. And if you look at the slide, you can see this information regarding magnetic field strength and what you're going to see soon. But specifically, as a part of this workshop, we're going to use MATLAB Mobile for exercises. So with this in mind, what are we going to do? We're going to continue and see about how we can use what we've just heard about as a part of this particular workshop. So now that you've learned about sensors, let's start to explore what we can get access to in terms of our upcoming exercises. So the overall goal for the exercises entails us aiming to make sense of the collected data regarding the magnetometer with the first exercise and the accelerometer for the second exercise. So we're trying to collect the data and see what we get out of the collected data, and then try to figure out, well, what was happening as the data was being collected in terms of movement. The main goal of the first exercise is to see, based on the collected values, if there are indicators that there seem to be outliers in the collected values. The idea is the outliers may be the presence of metal objects. In terms of the second exercise, what you're going to see is trying to collect your movement information. After you collect your movement information, we're then going to use machine learning to classify this movement and see what was happening as you were collecting this data. So there are two exercises you're going to do as part of this workshop. Now, in terms of the pre-work And another step, I'm just going to build out the slide. It's not just about enabling the sensors, but also being able to find the code that's already been written for us and being able to run that code. If you look closely at the screen, you'll see the 3 lines that are going to highlight, okay, getting access to a menu. This time you're going to visit Files. Once you visit Files, make certain you're in MATLAB Drive. The same MATLAB Drive you should get access to. Select this particular folder, Met, Det, AI, and IoT Workshop. Find this first file. We're going to try to do that first exercise soon. And you should be able to see the code for that first exercise. And you'll notice you should be able to press this arrow. That's the run button to help you execute that code once it's time to do that first exercise. And keep in mind, these same screenshots will be available in the handouts that are available that you'll see in the chat that we as the instructors and the teaching assistants will provide to you. Now that hopefully you're set up, I'm going to hand off to my colleague, Lauren.
All right, the real work begins now. With this introduction, let's start with exercise number 1. And just a quick note on the exercises. Each exercise is independent of the other ones. So if for some reason you were not successful at finishing one of them, you don't have to worry and try to catch up for the next one because each one runs independently. Okay, so now we're ready to go to exercise 1. And open up your MATLAB Mobile app and go to the folder that has EX1 under collect and visualize data.m. And when you select that, open it up and then select the run button. And when you do, it will start running and you will see a spinning wheel after a while saying that it's evaluating. This is when you get up and walk around and bring your phone closer to different kinds of objects, you know, maybe some glasses, maybe the toaster if you're near the kitchen, different sorts of things. And it will actually go for 20 seconds without you having to count it out. And then it will finish and you will get a few visualizations. So I'm going to let you do that here. And then Lou and I are going to talk a little bit about what we found. Lou,
thank you, Lauren.
When you did this the first time, what did you sort of see?
You know, it's a great question, Lauren. So one item I saw is I was in my kitchen area and I put the sensor close to my microwave and I saw a significant change in the values in terms of the range of the values. That's what I happened to see. Did you see anything of interest?
Well, I didn't at first because I opened up my closet and it turned out in my closet there were things like hats and gloves. So there was nothing there. And I went, aha. And so then I went over and I went near my TV. And of course, it began to spike up when I saw that, when I got there.
Okay, interesting. Yeah, it'll be interesting to see what the audience members get as they run through this exercise.
And feel free to put something in the chat if you'd like about what you're finding. Are you finding that the magnetometer starts wiggling a whole lot when you get near certain items? And that would be interesting to find out.
I agree.
I actually also found that one of my winter boots must have some steel in it, in the toe, because my boot lit up.
Oh, that is interesting. I'm curious, were you able to visibly see the steel or no?
No.
Oh.
No, it's in like the shank of the boot, you know, like in the sole kind of.
Yeah.
Yeah.
Oh, that's interesting. You know, you brought up something that I've always thought about. Sometimes when I go through airport security, I know some individuals are stopped because of their shoes and they must have metal. Wow.
Yeah.
Interesting.
You sometimes hear about, you know, like the people who work construction, they often wear steel toe boots, so that if anything big falls on their feet, they don't crush their foot.
Exactly. And I'm curious about seeing, you know, some of these answers we're getting through the chat. You know, please interact with us in the chat. Let us know what your results are showing. And it looks like we have a little bit of a timer, so they have about 30 seconds left, it looks like.
That's right. So hopefully, if you have been having any problems, you've been putting it in the chat, and our TIs would be helping you. And otherwise, we'll be moving on in just a couple seconds.
And with that in mind, I guess I will, leave you to continue. Thank you.
Sure. Okay, so by now, you've learned how to acquire magnetometer data from your device, and you maybe saw some anomalies visually as you ran the rest of the script. And you can see what my data looked like. Your data may look similar, but it won't look exactly the same because you measured different things than I measured. But here's 3 different ways that we might visualize things. And we'll go into some of the visualizations in more detail as Sarah takes you forward.
Thank you, Lauren. Okay, so let's revisit the roadmap that we have for the workshop. In the last exercise, you learned about collecting sensor data and exploring using the magnetometer. But we told you that you were going to explore some other aspects of the scene around you, like what you're doing while the data is being collected. So next, you're going to incorporate some artificial intelligence, or AI, to make some guesses about your activity. Due to the limited time for data collection that you had in the previous exercise, some of you might have tried to expedite the process a little bit. So maybe some of you were moving around the room, walking around, but maybe some of you were still seated while collecting the data. And typically with data collection, it's helpful to have some insight about what was happening as the data was being collected. So for example, you might want to know if there was dropout during the data collection process, a hole or something in the data, what might account for that. So knowing what you're doing, or even where you were doing it, might impact the calculations that you do and the type of data analysis that you need to perform as well. In the next exercise, we'll collect data from another sensor, the accelerometer, and classify it to determine what you were doing as the data was being collected. So what does an accelerometer do? An accelerometer can detect acceleration, vibration, and tilt to determine movement and orientation along the 3 axes. So an accelerometer can determine how fast you're accelerating in any linear direction. Some of you might have also heard of this before as a G sensor or an orientation sensor. And it's a really useful sensor to have. In your phone, for example, it uses an accelerometer to determine if the phone is in portrait or landscape orientation, or whether it's face up or face down. So in the upcoming exercise, you'll collect accelerometer data and then use it to understand what activities you are performing as you move. Once again, we'll use MATLAB Mobile for this exercise. Before, you were using the magnetometer, and in the next exercise, you'll collect data from the accelerometer. So we're going to use some AI today. And this is a tool that we increasingly see in many different parts of our lives, from our speakers, our smart home devices, to our cars. Today, you're going to use machine learning to classify your movement using the accelerometer data that you collect. And more specifically, you're going to use k-nearest neighbors. So let's start with an overview of our workflow. We have some data that's collected from your phones, and we'd like to pass it to a model that can return a label for what activities were detected over time. So those activities could be staying idle, could be running, or maybe you were walking. To create the model, we have a couple of other high-level steps if we open up this black box. And the first step is to extract features from the raw accelerometer data. Right? We don't want to feed all of the raw accelerometer data that you collected to train the model all at once. Instead, we want to extract some more meaningful information from it. In our case, feature extraction is going to mean parsing the raw data in smaller windows of time so that we can see what changed in those windows. Once we've extracted those features from the data, we train the model. There are many different models that we could use, but in this workshop today, we're going to use k-nearest neighbors, or KNN. And KNN is all about finding the K closest points to some query point, some new data point that comes in. There are different ways that you can measure closeness using different distance metrics. And there are different values that you can use for K, which is the number of neighbors that you compare when you're determining how to classify a new data point. So in this diagram, let's say that a smiley face is our new data point, that's our query point. And we're going to use a value of K equal to 3, meaning we're going to compare to the 3 closest neighbors. And for distance, we're just going to use Euclidean distance here. So in this diagram, the 2 red icons and the 1 orange icon are the 3 nearest neighbors. So 2 are walking, and the orange one is standing. So since the majority of the neighbors are walking, we classify the query point as walking as well. And as you'll soon see, the results that you get will depend on lots of different factors, like the number of neighbors and similarity of the new query point to all of the training data that we originally had. All right, so if we move on to the next slide, now that you've learned about machine learning, you'll apply it to accelerometer data. In exercise 1, you learned about the magnetometer on your phone, and you demonstrated ways that you could analyze the data, and now you're going to get started with exercise 2. So here you'll collect some new data from the accelerometer and apply machine learning to predict whether you were walking or running or staying idle. All right, so once you've run the exercise, you don't need to do this yet, but after you've run the exercise, you'll see a plot with a breakdown of the different activities over time. So this is an example of what the results might look like. So you can see activities across time, which is on the x-axis, and then you should see, 3 sort of horizontal lines that correspond to the 3 different activities that the model can predict, which were running, walking, or staying idle. Each dot on this plot corresponds to, each time step at which you were doing the activity, roughly. All right, so this is just some background information for what you will do when you run the exercise, but we're not there yet, so hold on. In the file exercise 2 classify activity, what you'll do is either walk or run or stay idle for 30 seconds, and the code will track those 30 seconds for you. Once those 30 seconds have passed, you can view that plot of your activity, and if you have extra time, you can run the code multiple times as well. So next, I'm going to hand it over to Shruti, who's going to talk about IoT.
Thank you, Sarah. So let's see, what is this all buzz about Internet of Things or IoT? So let's go over a typical IoT workflow. What does that look like? We start by collecting data. There are many smart devices out there that are generating data. Can you think of any such devices? Let us know via the chat window. Few devices that I can think of are Nest thermostat, smart bulbs, Fitbit, or even mobile devices. Today, we collected data generated by our mobile device. The next step of IoT workflow is to analyze. We analyze the collected data. Today, we applied the KNN machine learning algorithm to the sensor data that we collected. The third and the last step of IoT workflow is act. We act based on the collected and analyzed data. Act can be sending emails or even making social media updates, like tweeting based on the analyzed data. Let me give you a quick example of IoT at my home. I have a Nest thermostat set up in my living room. If the temperature of the room goes above 80 degrees, I get an email. Now, sending an email is the act part of IoT workflow. So let's continue. Today, we are going to use ThingSpeak, which is an open IoT platform with MATLAB Analytics as an IoT aggregator for us. If you go to thingspeak.com, you should be able to see something like this. We don't expect you to be able to read any of this, but what we would like to highlight here is that ThingSpeak is used for a wide variety of applications, from smart farming to weather monitoring. Next, we would need to create a channel where we can store all the sensor data. So before I start talking about channel, etc., I should tell you what a channel is. Channel is a location where we store data which can be retrieved later on. Each channel is unique and is identified by a unique number. As part of our take-home exercise, you will have the opportunity to create your own ThingSpeak channels. Let's continue. Okay, so now let's move on to our next hands-on exercise, which is exercise 2. I want to go over few code in the exercise that we have at a high level. As Sarah told us, the goal of our exercise is to classify data and send it to our IoT aggregator. So what Sarah explained to us today was how to collect this data and how to analyze it, how to classify the activity as you run, walk, or just stand still using machine learning algorithm. But what do you do after that? For those of you who might be using Fitbit or Apple Watch, you might be competing with your friends to see who took more number of steps. And how do we achieve that? Using IoT. And that is what I'm going to tell you today. So first, we begin by using MATLAB command called ThingSpeak Write to send data to ThingSpeak. Next, we use MATLAB command called ThingSpeak Read to read data that we just wrote to the channel that we have created. As you can see, the first input argument here is the channel ID. This is the channel to which we have written our data. The next input argument is number of minutes. We want to read all the data that was written to this channel in the last 1 hour. And finally, we want to be able to see this data in a table format. Okay, next, click please. This last step is to visualize the data in an histogram format. Okay, so now let's see what kind of data we got when Lauren, Lou, Sarah, and we were doing this exercise. So let's see. This is the kind of histogram we got. As you can see, during the exercise, we were running for the most part. Now let's see what kind of output you get. Are you going to be active? Are you going to be walking? Let's find that out. And now I hand it over to Sarah, who will tell us how to run this exercise. Over to you, Sarah.
Thank you, Shruti. All right, the time has come to run the code. So if you open up the file, exercise 2, ThingSpeak AI and IoT, you should be able to click on the triangle button at the top of the window there in order to run the code. So go ahead and enter a team ID and then press the return key. So once you press return, you'll be prompted to start moving around and the data will start to log. So do, a combination of different activities for those 30 seconds. And then at the end, we'll view the fitness activity that was sent to the ThingSpeak channel across all of the teams. So if you're not sure which team ID to use, go ahead and just pick one, or perhaps we and our TAs can help to assign some of you to different teams in the chat window. So go ahead and we'll take a few minutes to run this exercise. So Shruti, I think the last time that we did this activity together, it was I think all of us on here were in different teams competing against one another. This might have been, before we all started working remotely, but do you remember what happened when we each were collecting data and submitting it to the channel? I can't remember who won.
I forget who won. but I do remember interesting things and interesting results that we got. I don't think our data was always accurate. By that, I mean the classification accuracy was not 100%. Do you know what might have impacted that?
Yeah, there were a lot of different factors from what I remember. One of the things that I think we noticed was that each of us was kind of holding the phone in a slightly different way. So some of us were holding the phone in front of us because, we wanted to watch what was happening in MATLAB Mobile. But it seemed like the model gave better results if you weren't holding it in front of you. So I think, if you had it in your hand at your side and kind of tried to walk a little bit more naturally, then the model did a better job of classifying the activity.
Right. I'm just curious. So for this exercise, we are using accelerometer. We use magnetometer in the previous exercise. What are some other sensors that we can possibly collect data from? And this is question to all our participants as well. Let us know via the chat window. What are other sensors that you can collect data from? And what are some creative applications that you can build using the sensor data that you will collect? What do you think, Sarah? What other sensor can we collect data from?
So I think we've got a few here in MATLAB Mobile. So other than the accelerometer and our magnetometer that we've been using so far, we can also collect, I think, location data. I think we can collect some gyroscope data, and there are a few different sensors as well, right?
Right. A GPS is one of them, like you said. So there is room for a lot of creativity to build interesting applications.
Let's go ahead and discuss some of the results that we all saw. So hopefully you all got decent classification scores and were able to send some data up to the channel. Let us know in the chat window though, what did the results look like for you? Was the model still doing a decent job? Were there factors like, how you were holding your phone that might have affected the results that you got? And here are just some things that you can think about that might affect the model accuracy here. So we mentioned earlier that factors like the number of neighbors that we're using in KNN, or even whether new data that you're collecting looks similar to the training data set that was used to fit the model. Those are all things that can really greatly impact the accuracy of the model. So in the code, we were using k equals to 10 neighbors, but perhaps you could try and fine tune that or fine tune other parameters in the model to try and get a slightly better result. Or perhaps it's the case that the training data doesn't have very good coverage of the different ways that many different people move. So let us know in the chat window how the results looked for you. And as Shruti was mentioning, are there other types of sensors that we might be able to collect data from to get some interesting results here? All right, so with that, I think we're going to move ahead to the next section, which Louver is going to lead.
Thank you very much, Sarah. And with this in mind, Shruti and Sarah raised some very good questions. So thank you to both Shruti and Sarah. A lot of the data that was collected seems to have a dependency on knowing our location. This leads to a few questions. Why should we explore collecting location data? And what do we even mean by location data? Location data that I'm referring to are latitude and longitude values of where each of us is located. Location data would be especially helpful for this application because magnetic field strength varies according to geographic location. And to get more accurate magnetic field strength values, the location should be taken into account. For instance, the magnetic field strength of Cambridge, Massachusetts, which I am close to, is measured at 58 microteslas. In terms of the activity data, location can be helpful to determine if there is movement from one location to another. However, Another question appears. Do you want to collect location data? And although location data can be beneficial to this application, at least one question may occur for many of us. And I'm inviting my colleagues, Sarah, Shruti, and Lauren, to come back so we can have a brief discussion about this topic. So here's a question I have for all of us. And these are actually two questions. Who is possibly going to have access to our location data, and how could this information be used? We've seen location data used for targeted advertisement, other applications, but I'm, just curious because in this workshop, we made a conscious decision to not collect location data. So I'm curious, in addition to the other questions, you could answer any of those, but, do you know of any examples where location data was not handled in a clear and transparent manner? Are you aware of any issues or concerns that were identified as a part of these examples? So anyone, if you're comfortable, please answer any of those questions.
Well, I read an interesting article in the New York Times last week, and it was this reporter who, with her husband agreeing, she planted a bunch of GPS sensors on him and then said, go about your day. And they live in New York, and she tracked him all over the subway and to the coffee shop and you name it. But again, he had agreed. But what they found out afterwards is, even though he had agreed to it, he felt kind of creepy afterwards that she knew so much. Not that there was anything he was hiding. And then also around that same time, I began to hear about some of those ID tags that Apple uses, that some people were like attaching them to someone's car and then using it to track that other person's car without their knowledge. And so that's kind of uncomfortable. Someone who you don't want tracking you could track you potentially. And so in this case, we were extremely mindful that we wanted to preserve only data that couldn't identify you in any reasonable way here. So acceleration doesn't tell you where you are in the world. It just tells you how fast you were moving.
And thank you, Lauren, for sharing that example. And I think a lot of us have gotten exposure to thinking about these considerations with location data. There's so many of the apps that we have in our mobile devices that are asking to track us in a variety of ways. And there's so many articles and studies that have identified these topics as well, based on a number of the items that Lauren has mentioned that I'm sure a few of us in the audience are thinking about. And please feel free to share in the chat. Is a lot of the terms associated with these topics tend to be related to, location data. Sometimes they say geospatial data and ethics, because there are a lot of concerns related to this data. And thank you so much for the insight that's provided, because I think this is something we need to keep in mind as we're collecting this data and analyzing this data. And thank you for joining us during our workshop overall, where we provided an overview of how we could explore gathering, visualizing, analyzing sensor data for the goals of scene exploration, plus obtaining more insight into how the data was collected. However, these are not the only examples of using sensors, AI, and IoT. There are numerous other examples. And in our additional resources, we're going to share links to all these stories that are identified through these images on the slide. They're really interesting stories that highlight how to use all three of these items together. Thank you for your attention and engagement today. We encourage you to keep in touch. You have our contact information on the slide, and we can't wait to hear how much more work you do related to sensors, AI, and IoT, which, by the way, are large pieces of working in data science. So keep that in mind. Please use the hashtag SheLovesMATLAB or MetDetAI and IoT to keep us in the loop. We would also be happy to bring this workshop to your university or organization on behalf of all of my colleagues. Thank you again for your time and attention. We hope you enjoy the rest of the WIDS 2022 Worldwide Conference. Thank you so very much.